Okay, you go to MyJag. This is the home page of our class. Notice 2 things. Aha, Chapter 4 practice test solutions are posted. Wait, what is this underneath? Plan for rest of semester. So you know exactly what we're doing every day. Today's 4.4. Tomorrow's 4.5. These are significantly shorter lessons, and it's better. 4.6 is on Monday. Tuesday, we review, then wait, what is this? The test is not the 3rd. I moved it to the 5th, so we can have 1 day review after Thanksgiving. Yes, that gives you plenty of time to come and ask questions. Wonderful.
Thank you.
So, there you go. And whoa, what are we doing after that? Reviewing each chapter 4 a day, and then on the 13th, general questions. So you bring in, and any question where you're like, I don't understand it, the 13th is the day where it's like your questions. Perfect. There'll be classwork grades associated with every single one of these days. They'll be like, we're going to do mad review. Cool. So instead of covering 5.1 and 5.2 like I planned, we'll just start chapter 5 fresh in the new semester. This means you should get a good grade on your final. But this also means you have to study for the final outside of class. Okay? Coolio. I'm going to give you a packet after we take the test. As soon as the clock and calendar hit December, I'll answer things about the final. Yep, it is November. Let's focus on the chapter 4 test. This is on the front of MyJag. Coolio. You know exactly what's happening. Awesome.
Also, is the chapter 4 class, is it going to be like bigger than all the other tests? We're not just going to do so much stuff.
I mean, as lengthwise, I have to make it sure it's finishable in 1 period.
Right.
It has to be the same length as all your other. But on the final, it may be a little more than a 4th. It might be like a 1/3 of the questions on the final. Yeah. Cool. And finals are around 40 to 50 questions because it's supposed to be twice as long as a regular test. And regular tests are about 20. Okay. Team, we have our notes out. We have our notes to 4.4. All right, we have our notes out. We have a writing utensil, a pencil. You have your calculator out. Okay.
I'm prepared.
Wonderful. I'm glad we're all on the same page. Let's do this. So, 4.4, complex numbers. Up to now, you have learned about real numbers. Today, for the first time, you will be covering things that are not real, aka imaginary. So, top of page 34, we are covering imaginary numbers. Not just imaginary, but complex. So first, what is imaginary? Oh my gosh, an imaginary number is this I. Oops. Yeah. So, I mean, we're going to use imaginary numbers a little bit. In pre-calculus, there's like a chapter for like a section where we use it. In calculus, so I'm showing you like where you use it. Why is this the first time you learned it? All right, so we briefly cover it here. Then pre-cal, it's like, okay, like a section. And then in calculus, it's a whole chapter. And then as you go higher and higher level maths, you use this imaginary more and more. Because, so math is a language. Same way English, there's letters and words, and you can use these letters and words to like describe the world. You can use math to describe the world and see what's happening. That's what physics is. Physics is a poem describing the world. Okay, that's really like dumb of me to say. Let me revise. Physics is using the language of math to describe and predict what's happening in the world. So imaginary numbers, I don't have to tell you where this is coming from. That's fine. I just figure you like, you know, people are like, when am I going to see this? Blah, blah, blah. Look at your phone, right? Your phone, literally, in order to figure out the current and all the semiconductors that are in there and all of the hardware components, there's a lot of math involved. How do I make sure I don't blow my phone up when I charge it? So the math involved with electricity and magnetism deal with I in it. And if you get really hard math, so upper level, like hard calculus, and then the things that are after calculus, they also use I. Anyway, so that's like, you may use it more, but I want you to understand, like, it is technically in your life. Do you guys know those like saloon doors or like things that like wobble back and forth and gently like dampen out? Maybe in like a kitchen or something. You know, there's like doors that you open and then out. So you can model the motion of those with a sine function, which is trig, and it uses I as part of the math. Yeah, that's about as simple as I can explain it. So we use it a lot of places, but it's really like behind the scenes. I is an imaginary number. So what is it? So I is the square root of -1, and you have to know this. I don't tell you this, you have to know it. So up till now, you've never had to deal with numbers, square root of negative numbers. Now you know how to deal with them. They're not real, they are imaginary numbers. So pure imaginary numbers only have imaginary terms. 3i, -2/3 I times √3. Those all just have an I in them. Versus if you have a complex number, they have a real component and they have an imaginary component. So you have something without I plus something with I. Something without I plus something with I. Okay, so that's complex. Step by step. So you may be like, where is this even coming from? What the heck? As long as you know I is an imaginary number. The definition of I, square root, -1. That's what you have to know. Let's take 2 seconds to review a little bit of Algebra 1. If I said, what is the square root of 4? 2. Okay, so we know that's true. And we know 2 times 2 is 4, right? So I can rewrite this as saying square root 4 times square root 4 is equal to 4, right? Because if you have a square root and you're squaring it, literally multiplying it by itself, what happens is the square and the square root cancel out. So we're cool with that. Okay, 2 things. 1, I already asked people to put their phones over there, and 2, it needs to be silent. So put your phone over there. Okay, so if we have a square root and I'm squaring it, the square and the square root cancel out. So we're good with that. A square root being squared cancels. That is review number 1 that we have to be like cool with to understand this lesson. Okay. Another way of saying this though, what do I do? When I have a radical being multiplied by the radical, I can simplify it by writing them both under the radical and multiplying. So you can multiply what's under the radical. What's 4 times 4 again? 16, and what's the square root of 16? 4. 4, right? Because 4 times 4 is 16. Okay, so the first thing I covered was if you have a square root and you square it, they cancel. The second thing is when you're multiplying 2 radicals, what you can do is multiply what's inside and then combine them to write them under the same radical. Okay, so let's use this fact and go the opposite way. So if I would have something like square root of 12, how could I rewrite this? Yeah, tall. Say it again. Root 4 times root 3, because you're saying like 3 squared, or 3. I just heard you say 3. Okay. Is this right? Is 12 4 times 3?
Yeah.
Okay, so I could divide it out like this. So saying root 12 is the same thing as saying root 4 times root 3. Okay. Do we know what root 4 is? 2. So root 12 is the same thing as 2 times root 3. So being able to split a radical, yeah, perfect. Great. Jogging memory. So now this lesson will make a little more sense. So we have to be able to split a radical, and we have to be able to square a square root and know that they cancel each other out. So now we're ready for operations with imaginary numbers. Sorry, do we have questions? I'll make sure I'm not going too fast.
Yo, this is hella confusing.
So, yes.
What's the point of I?
Got it.
Like that's what I don't understand. Like imaginary number, but like what does that mean?
So,
Number of imaginary.
okay, before I answer that, do we understand the 2 things I was showing you here? Right? Square root, squared, cancel, and then I can break a radical into, okay. So,
All numbers have been invented, but they can't fit in that kind of
not quite, it's okay, not quite. It's fine.
Numbers have already been invented.
That's really a philosophy question, because it's like, are numbers invented, or are they found? Like, ooh, okay.
Is math found?
Exactly. That's a philosophy.
So weird.
Hey, you're welcome. You should take a philosophy of math class.
Uh,
If you don't like this class, you will not like that class. Okay.
I think I might have to take it then. I love this class.
I don't know how to respond to that. Okay. So, I don't know. Okay. So let's. Okay. So, throw back to 4.2. How many solutions does this have? 2. Okay, cool. So example, if this was like -1 and 1, this would be like x squared minus 1, right? That would be what the equation would be. Because you factor it, right? You factor it, x minus 1 times x plus 1, because it's a difference of squares. And then the two roots, the two solutions, x-intercept, zeros, remember, those all mean the same thing, are 1 and -1, because you set each factor equal to 0. Are we okay with that one? Cool. So we had 2 real solutions. Awesome. What about if I had something like that? How many solutions? 1. So this happens when you have a perfect square trinomial. So for example, this would be when you have like an x plus 1, x minus 1 times x minus 1. So this would be the equation x squared minus 2x plus 1. It's a perfect square trinomial. The 0, the 1 root we have, because both of these binomials are the exact same thing. You get the same number, so wait, there's secretly only one solution. I mean, you could write like, oh, here we see x equals -1 and 1. On this middle example, you see x equals 1 and 1. Wait, what? It's the exact same number in the middle because you have the same binomial twice. So quadratic always has 2 solutions. The issue is, what happens when I have a quadratic like this? How many solutions? 0. But technically, every quadratic is supposed to have 2 solutions. So the 2 solutions here are the imaginary ones. Tal was asking, where is this going? If you don't have any x-intercepts, you will still have 2 solutions in the sense that they're going to be imaginary. Both of your solutions would be imaginary. Do you remember the quadratic formula? Negative b plus or minus
4ac
b squared minus 4ac all over 2a. Okay. So you plug your quadratic into that and you will find 2 imaginary solutions. So teaching you 4.4 is because in 4.6 we go over the quadratic equation and we're going to have to deal with radicals with a negative under them. That's where we're going with this. I did not cover this in my other section because it takes a lot of time and it's also very hard conceptually to grasp. Yeah.
So the one with one solution has one imaginary solution?
It's 2. It's technically a repeated root. Both are real, but it's the same number. So although both of the numbers are 1, but really it only touches the x-axis at one point. Yeah. Okay. So this would be like x squared plus 4. Because if I try factoring this is not a difference of squares. Secretly, the solution would be x minus 2i, x plus 2i. And we're going to get to that in about 20 minutes. You would see that this would be the roots. Because technically, the solutions would be 2i and -2i. And you're like, what the hell? This is an I. Oh my god, where's this coming from? Oh, it's because it's not actually touching this x-axis, so I can't have a real number. It has to have an imaginary because it doesn't actually touch the x-axis. Okay. Sí, senor. Yes.
Okay, so
This is getting a little ahead of myself. I just want to go through operations start really at ground level with imaginary.
okay, because I was wondering, when we do the table and we plug in the -2, -1, 0, 1, 2, you get an imaginary over there.
No, because you're finding the xy coordinates.
Okay.
Yeah. It's when you set when you're trying to find the x intercepts and you set y equal to 0 and you're trying to factor. Well, we can't factor x plus 4, so you would put it into the quadratic equation, then you would find 2 imaginary solutions.
Okay.
Yeah. Okay, operations with imaginary numbers. So, this is going back to this guy right here that I'm circling. If I have a radical, I can break it down into 2 things being multiplied that are equivalent. So this first one, I want to simplify radical -18. So what I could do instead is say, this is the same thing as root -1 times root 18. Now I've taken the -1, right? Because when you multiply 2 radicals, it's the same thing as writing them under the same radical, just multiplied. We know what root of -1 is. That's just I. That is imaginary number, that is I. Do we know how to simplify the radical root 18? So I would like to write it, a little hinty, ready? Hinty hint. Up here when I was doing root 12, what I did was I looked for a factor of 12 that was a perfect square. 4 is a perfect square because 2 times 2 is 4. So 18, I would like to have a perfect square factor. What? 9 and 2. 9 is a perfect square. What times itself is 9? 3. Okay, awesome. So I'm going to rewrite 18 as root 9 times root 2, because technically 9 times 2 is 18. And what is the square root of 9? 3. So it's the same thing as I times 3 times root 2.
Does it matter where you place the I?
So the way I like writing it, but you have to be careful. You have to be very clear with your writing. I like to write as 3 root 2 I. Notice the I is not under the radical. I is not under the radical. It's not. I made it very clear. The radical ends over the 2, and then I have I.
Wait, hold on.
So you could write it this way as well. That's fine. That's fine. You could say 3I root 2. They're all being multiplied together.
What happened to the negative?
Negative
I.
root negative 1 is I.
Oh.
Okay. We've done one example. If you're done with this one, try B. If you have questions, we're going to work through it. Try out B. Try out B. Try out B. The first thing we should do, rewrite it. Root negative 1 times root 125.
If you always have
No,
to
it's freezing because it's cold outside.
So Ryan,
It rained
your
yesterday
other
and
class
today.
had a test for that?
My
Whatever class my sister's in.
pre-cal, they had a test yesterday.
Okay, 'cause this is impressive.
Okay. You need me to take it out, please?
Yes, he needs to take it out. Should you always get negative 1?
Well, if I have a negative under radical, that's how you deal with it.
Is it?
Yeah.
I mean, who deals?
Question.
Is it 5 root 5I?
5 root 5I. Yep. Okay, 125. I'm going to do some prime factorization. 125 is 5 times 25. So I can rewrite this as root 25 times 5. I know that, give me 2.
I can just put it down if you want.
No, it's not be after starting the class. And like set it.
Make him feel bad.
No. Just to log in as her. I don't think you have to. I don't think so. Okay. So let's finish this problem, then I'll take your press test. So, question? Yeah, of course. You just bring it over. What? You guys are wild. Let's calm it down. Let's calm it down.
I didn't know he was going to do it. I wasn't really paying attention.
You're very flattering.
So, yes, I had him last year, and I had Yonatan the year before. This is the third year of having a Leshem.
That's so
Doesn't it?
All right, here we go.
What?
Here we go. Here we go. Since last year, there has been some growth.
I don't.
Okay, so ready? Here we go. What? Shh. What? Ready and focus. Root negative 1 is equal to I. Square root 25, 5 root 5. So I could write this as 5 root 5I. Notice, I is not under the radical. If you write I under the radical, I'm going to take points off. You must not write under the radical. You must not write I under the radical. Don't be sloppy with your handwriting. You cannot have I under the radical. There'll be points off. It's not equivalent. Okay.
You keep on.
Cool. So there's like, notice it's not under the radical. Oh my God. Okay. Oh, here we go. We just did root 81. Please stop talking. 3, 2, 1, stop talking. Who's gonna mark down? I'm done. We're going. So we did root negative 81. What we did, we wrote it as root negative 1 times root 81.
9.
Root of negative 1 is I. The square root of 81 is 9. 9 times I is 9I. Cool. What? Okay, so we're okay with this one.
Yeah,
Okay.
because you can't square root a negative. I was just brain farting.
Yes. So this whole lesson is dealing with the fact that you can't square root a negative. So how do we do it? Pull out the negative 1, and now we'll have I, imaginary. So this next part deals with this little part of the review. So we said
Y'all better stop.
you can give him gum without talking. You don't have to like talk, okay? Just be like, here.
That's talking though.
No, this isn't.
Oh, I think that here.
So what happens when you square a square root?
Cancels out.
It cancels. One more time. If you square a square root, it cancels.
out.
Okay. So we just all said it together. If I is equal to root negative 1, what if I square both sides? Right? So this means I squared is going to be negative 1.
Wait, but I thought it was. Oh, because it cancels.
Because the square and the square root cancel out. I just had you say this 5 times in a row. I just had you explain it.
Oh yeah, so then if you want that, so I
I really want to get through this lesson. If not, there's a screencast online. So, oh yeah. Okay, I squared is negative 1. So anytime you see an I squared, you can plug in a negative 1 instead. Yeah, put it away. So let's go ahead and simplify. What is 3i times 4i? 3 times 4 is 12i squared. Wait, this is the same thing as 12 times negative 1. So it's going to be negative 12.
Who decided it was negative 1?
From the definition. I is defined to be square root negative 1. So if I square both sides.
But like, who made I go for square negative 1?
So that's the simplest. This is the simplest way to deal with the negative under the radical. If we just define negative 1, square root negative 1 to be I, then like anytime I have a negative under a radical, I can pull out the negative 1 and just make it into I. Because I know it's not actually going to be a real solution, because you only can put positive things under a radical. So we had to have a way to deal with negatives, because like, what the heck? What the heck is with this negative under a radical? So this is our way of dealing with it. Yeah. Okay. Let's try the next one. First thing I need to do is multiply them together. So I am going to write this as square root of negative 12 times negative 2.
You can you multiply? Is that positive 24?
Positive 24.
And then it'd be 12.
So think to yourself. Don't say it out loud. Not so much. So I want to rewrite 24 as two things being multiplied, but one of them has to be a square. Do we have is a square, perfect square, one of the factors? So remember, the perfect squares are 1, 4, 9, 16, 25, 36, 49. Those are perfect squares. So this is going to equal root 4 times root 6.
Dude, you're mapping out.
Right? Because 4 is a perfect square, and 4 times 6 is 24. So the root of 4 is 2. So 2 root 6 is our answer. No. Okay, let's try the next one. Yeah. I'm trying to give people time to write this down. 2 more seconds. Tal, what's your question? It's definitely not about math. Okay. Okay. So, yes.
How do you know when to put I in the multiply?
If you have a negative under your radical. Did we have a negative under a radical in B? At first, but after I multiplied and simplified it out, I didn't.
So.
Okay. So you multiply them together first. Factor and solve. Did that answer your question? If you have a negative under your radical, you have to have an I. Tal, where are your notes?
Oh, because there's two negatives, it cancels the negative out.
Okay, so have other paper out so you can like write stuff down. So when I have you like try a problem, you could try it.
No, I was actually thinking to do that. Like, for real.
Okay. Factor and solve. Let's get x by itself. So it doesn't just say solve for x, it says factor and solve. What done? What's your question?
You had an answer.
What's your answer?
Divide by 4.
Divide by 4, okay.
See that though.
X squared equals negative 25. So I can take the square root of both sides. So x is going to be plus or minus the square root of negative 25. Now this is very subtle. Before, we didn't have to deal with the plus or minus. I was giving you the radical. So up here, I gave you the radical. The previous page, I gave you the radical. So you were just computing. You were just like solving for it. But when you are introducing the radical, aka I had x squared, where did the radical come from? Oh, I wrote it. When you are writing the radical, you are taking the radical to actually solve. It wasn't on the paper to begin with. You have to include the plus or minus in the solution. So this is the difference between x equals root negative 25 and x squared equals negative 25. This top one, it's just going to be 5i. But when I'm actually trying to solve for x squared, there's going to be two solutions because there's two different things I could plug in to make this true. I could plug in a negative 5i or a positive 5i for this one. So there's actually two solutions. Let me do one without an imaginary. That way it makes a little more sense. So I'm going to do an example without I, just so like it's a little easier to understand. What's the question? Do you just want to wait like 2? Fine, go. It's fine. I'm screencasting anyway. Go ahead. So if I had, if I had x equals root 9, this is equal to 3. But if I have x squared is equal to 9, there's two different answers I could plug in. I could plug in negative 3 or I could plug in positive 3. This is why. When I'm actually solving it and I have to take square root of both sides, I have to include the plus and the minus because there'll be two solutions. Versus the top one where I gave you the radical and you're trying to solve, there's only one. So it's very subtle. I put a note, like this was on your MyJag for like 2 or 3 weeks on the front page, like describing this. So I was hoping you guys would like read it because I told you, read it. Don't think you did. So I'm explaining it right now. It's very subtle. When do you include the plus minus? When you are taking the square root to solve. So this bottom part, we had to take the square root on both sides to solve for x. Versus the top one, I knew when I was just given the root 9, I could just say 3. Does that make a little more sense? When you are introducing, you are putting the radical on your paper. It was not there before. You have to include the plus or minus. When it's given to you, it's printed on your paper, you just compute as normal. If I gave you something like x equals negative root 9, okay, well, this should just be negative 3. Because there's a negative in front and root 9 is 3. When you just have the radical printed on the paper, it's defined to be the positive solution. When you are taking the radical, you have to include both plus and minus. Okay. That's a little aside. So that's why we have to have plus or minus down here. All right, let's try B. Yeah.
So, like, remember when we learned, like, when we look at everything, and, like, the farthest right was, like, where it is on the graph?
The y-intercept, yeah.
Yeah, and then, like, the middle part was, like, the slope, or, like, how much it moved left and right. Like, what's the difference between those?
Much moved left and right. Oh, so that has to be in vertex form. These are not in vertex form.
Okay, but it's, like, all the same stuff. Like, is it all, like with the same?
So if I rewrote, okay, I think I see where you're going with this. So if I rewrote this as y equals 4 times x squared plus 100, move 100 on the other side. It's really like you take x squared, multiply by 4, so it's much skinnier, and then add 100 to it. So this is so far, up. That's why we have two solutions, but they're both imaginary.
But it would be the same, like, shape.
What?
It would be like the same shape, like it would be the same.
Yeah, it's still parabola.
Or
Still parabola.
So
That didn't answer your question?
No, yeah, I did answer my question. Like, I guess on the note one, if it was like, if it had any correlation to each other.
Yeah, so this graph is shifted 20 up, and then it's 5 times more skinnier, but it's not actually touching the x-axis. So
Really high.
we're still going to get two solutions, but they're both will be imaginary.
Yeah, that's what the eye is for.
Yep. All right, so I need to get this by itself. It's fine. Get this by itself, yeah. Oh, okay. I'm gonna divide everything by 5. That way I have x squared plus 4. Okay, should I also subtract 20 first? Sorry. I think that'll be confusing. Subtract 20 first. Now I have 5x squared equals negative 20.
Yeah. And then you divide by
Divided by 5. X squared equals negative 4. And then to get this by itself, square root both sides. So plus or minus square root 4. So this is equal to plus minus root negative 1 times root 4. So this is equal plus or minus 2i. What? There's two solutions. You have positive 2i and negative 2i. That's what plus or minus means. Both solutions are right. Sorry, x equals plus or minus 2i. Okay, so fun with I. Yes.
when you're doing a plus or minus square root, do you always make the thing that's a positive?
Well, I meant to make this negative right here. Is that your question?
Yeah.
I'm just a little off this week. I think I'm really tired. I keep forgetting to write negatives in all my classes and solutions. But luckily, I show enough work that you see, oh yeah, it's supposed to be negative right there. I'm just being not with it. So I the first is just I. What if I have I squared? We know I times I is literally defined to be negative 1. Coolio, we solved that before. Because remember, if we take negative root 1 times root negative 1, the same thing as root negative 1 squared. Oops, just kidding, it's just negative 1 because the root and the square root cancel out. Gone. So, what you're going to see is there's a pattern. Have you guys ever played hopscotch?
Yes.
What's the pattern?
1,
2, 1, 2, 1, 2, 1, 2. Okay, here, the pattern's not so easy. There's actually 4 things. Instead of going 1, then 2, then repeating, 1, 2, repeating, like hopscotch, we have a 4 cycle of hopscotch that you're going to see. That's why there's 4 columns, and then there's 3 rows, because you're going to see the pattern repeating as we go through. Okay, let's try I cubed. So I cubed is literally just I times I times I. Wait, we know I squared is just negative 1. So this is the same thing as negative 1 times I, aka negative I. What?
Oh, wait.
Do I need to know this?
Yes, yes, you must know it. There is one question on your test. I gave you a practice test already.
3 eyes.
There's one question, just like this.
What's negative?
It's the negative square root of negative 1.
Why?
Okay. So for all of them, would it just be negative, or would it just be I?
Anytime you see I, it's
Negative 1
over
times
square
3. Oh, because negative I times negative number I is negative squared, which is negative 1.
What is negative? Is the square root of negative 1 squared?
Right?
This is what I wrote right here.
Dude, I don't understand this.
I squared is just I times I, right?
I'm saying.
It's like x squared is just x times x. Okay.
So then I cubed,
Yes,
would that just be negative 1 cubed?
So it's not.
What?
It's like what you wrote up there.
So I squared, right? I times I, we know is negative 1. So negative 1 times I is just going to be negative I.
Yeah.
It's not only worth 1 point. It's worth more than 1 point.
So how about
Okay. So what is I squared? Negative 1. And I times I is the same thing as I squared. I squared is negative 1. What is negative 1 times negative 1?
1.
1.
Oh my gosh. It's so blind.
It might take a sec for you guys to see the pattern, but it's fine.
Oh, it just goes.
It goes up 1 every time. It's hopscotch.
Well,
No, it's gonna go.
I mean, I'm doing that on
negative
purpose, so.
I. Oh, I see the pattern.
So, it's gonna be hard to see the pattern if we haven't actually completed the pattern
So
yet.
then would it be negative?
This is like asking you, what's the pattern for hopscotch when you've only hopped 1 square? We haven't actually gone through a whole nother cycle yet.
That's right.
Okay, now I'm going to do I to the 5th power. Okay.
Oh, right.
Okay, I want to make sure we finish everything. So if you have a question, raise your hand. Otherwise, I want it to be like minimal talking. You have a question?
Yeah, can I plug? Is this pluggable on the calculator?
Yes.
I get it.
So like,
But I may block it. I may block it for press test mode. Because there's a pattern and there's a way to do it. Okay, I to the 5th is literally I times I times I times I times I. 5 times. 5 times.
No, it'd just be I.
Hold on. I appreciate the enthusiasm, but it's kind of loud, and if I was a student, it'd be hard to focus. So I want it to be easy to focus. Okay. Stop talking. Okay, I'll show you. We're not done with this yet. So I times I, we know, right? I times I is the same thing as I squared. I squared is -1. So I have -1 times -1 times I. So I'm trying to rewrite this in terms of what we know. So you know -1 times -1 is just 1. 1 times I is just going to be I.
Got it.
What will the next... interesting. Now let's do I to the 6th power.
It's just I. No, it'd be -1.
I to the 6th power. I times I times I times I times I times I. Okay, that's 6. So it's -1,
-1, yeah.
-1, -1.
Oh, so it's -1.
I know -1 times -1 is 1.
For every 2, it's another. It's a square.
Oh, every 2?
Yeah. So negative. So 8 is also 1.
And so 10 would be negative.
Hoppy scotch. Look at us. Instead of 1 squared, 2 squared, it's I. -1. Negative I, 1. I, -1. Negative I, 1. So I'm highlighting on purpose. I to the 7th. 1, 2, 3, 4, 5, 6, 7. After this row, I'm not writing I's anymore.
Yeah, so that's a dot. It's a long dot.
Yeah. -1, -1, -1, I. So I know this turns into just 1, so this is just negative I. Because this is -1 times -1 is 1. And then -1 times I. 3 negatives make it negative. Because that's why I crossed out those two.
That's why also 3.
Yes.
Because when you have 1 left over,
I have a -1 that's left over. So that's why it's negative.
It's I. It'll be I.
So yep, this guy has no one to multiply with.
Okay.
I to the 8th. What is I to the 8th going to be?
That's a positive 1.
1. I to the 9.
That's a hella
I to the 10.
That's a -1.
I to 11.
That's a -5.
I to the
Y'all
12.
freaking me out.
Yeah.
So I just.
Okay, so if I asked you to do long division and we discussed remainders, would you be able to do it? Let me repeat it for the people who are talking.
Sorry.
Okay, I'm not going to be frustrated. I'll smart people off. Okay.
This is truly the worst.
Okay. All right, so you see there's a pattern. So if I have one remainder, so what I want to do is have you do a problem that's like, what is I to the 67th power? You do not want to go through this. Right, I 67 times and like group them. No, that sucks. Don't do that. What you see is there's a pattern. How many different options do you have? 4. So what I'm going to do, wait. Stop. No one talk. For like 5 seconds, I'll show you how to do it. Oh my gosh, show you how to do it. Okay, wait. So I take 67 and I'm going to divide by 4. Okay, what is, ready? 4 goes into 6 how many times? 1. All right, 4. How many times is 4 going to 27? 6 times. And what is the remainder? Remainder 3. So you look at how many are left over. What's the remainder? So what is 4 divided by 4? 1. How many remainder? 0. So this is the column where there's no remainder. No remainder? 1. What is, like 11? 11 divided by 4? 2 and 3 remainder. Okay, so this is the column when we have 3 remainder. 2 remainder, 1 remainder. So according to our calculation with our long division, 3 remainder, it would be negative I. What if I do something like this? I to the 32nd power. What is this equal to? Well, think about it. 32 divided by 4 is 32 divided by 4 is 8. How many remainder? 0. So it's just going to be 1. Awesome.
Always supposed to use 4.
How do we determine whether it's going to be?
How do you say
One,
negative?
negative I, negative 1?
How many remainder there is? How many remainder there is? 32 divided by 4 is 8 with no remainder. So I go in the 0 column.
So you know that's going to be 4.
Versus 67 at 3 remainder. So I go in the 3rd column.
So it's always going to be a remainder of 1, 2, 3, or 0.
Yes, because you're always dividing by 4. If you have a remainder of 5, you divide it wrong. Because we're dividing by 4. You should only have a remainder of 0, 1, 2, 3. Because we're dividing by 4. So there's a question like this on your practice test. There's a question like this on the real test. All right. I mean, I gave you the practice test first day of this chapter. There's a copy online, and the solutions are posted. So that gives you plenty of time to go over and get that 100 on the last test of this semester.
What is it?
5th. 5th in December.
And practice test is online.
Yes.
Wait, has it
I swear.
We have a page left, and I'd like to get through it. Are there questions? Questions, raise your hand. Otherwise, let us keep it inside ourselves with our mouths not making noise. Like, okay, like person to person, I think we'd all be cool. But I won't lie, sometimes you get on my nerves when you're talking. And I'm trying to instill knowledge on you so you can get good grades. Like, I do not enjoy giving out bad grades. I don't want to do that, but I also have to hold you accountable. You can't just be irresponsible, because when you actually leave D. Toledo and go to college, guess what? You're irresponsible. There's real consequences. I don't pay my rent. Oh, I'm late by an hour. I get charged. There's a late fee. Oh, 1 minute. No, it is due at 8 o'clock. Oh, I'm sorry. It's 8 o'clock with 2 seconds. Nope, not according to their system online. It's due at 8 o'clock. There's real consequences, so I'm trying to hold you accountable and help you learn.
For like a second?
Yes.
Like a big
Yes.
one?
These damn management companies with these apartments. Yes.
Dude,
Yeah.
I don't even wake up at 8 in the morning.
Anyway, I am trying to help you be more responsible, be a better citizen. Okay. Operations with complex numbers.
Has it
Yes.
ever happened to me?
No, I'm responsible and I always pay my rent on time.
You always pay like before.
Huh?
You always pay like way before.
No, because I wait till I get my paycheck. It's so expensive to live here. Okay. Operations with complex numbers. Operations. Adding, subtracting, multiplying. Last page of the notes. We just got to get through it. Imagine if we got through this and had 10 minutes left to work on homework. That'd be great. But no, we spend 10 minutes talking. Focus. Ready? We're going to focus. Next class, you could have 10 minutes to work on homework. Focus. So,
let's make that.
you only can combine like terms. You only combine like terms. If I have a real number, you only combine it with a real number. With a real number. If you have an imaginary term, you only can combine it with another imaginary term. Ready? Who's going to answer this question? You got to raise your hand. How do you know if something is a real term or imaginary? If there's an I, thank you for raising your hand, Jacob. If there's an I means an imaginary term. So I'm trying to add. What is 5i plus negative 3i?
2i.
2i.
It's 7.
3 plus 4 is 7 plus 2i. And that's it. You only can add real with real and imaginary with imaginary.
Let's go.
So yeah.
This should be this should be a nice simple question. Should be a nice simple question for your test. This should be a nice simple question for your test. Okay, let's do the next one. Notice there's a negative. what you will forget to do is distribute the negative. So I have 6 minus 5i minus 3 plus 2i plus 2i.
So it's negative 3i.
3 minus 3i. Because you only can combine like terms. Only can combine like numbers. Real numbers with real numbers. Imaginary with imaginary. You only can combine real with real and imaginary with imaginary. Yes. Good. I want it to be easy. So, whew, let's do this. Then sneeze. Okay.
Such a problem.
So, example 5.
No, it isn't. She just distributed. I'm totally focused.
Waiting. So, yes, I must distribute the 3i. Distribute the 3i to both terms. 3i times 2 is 3 times 2? 6. So 3i times 2 is 6i minus 15i squared. Ooh, what's I squared equal to? Negative 1.
It's our no. It's
Positive
already
15.
negative.
Positive 15. Catch.
Thank you.
Wonderful, wonderful. Okay. And the last question. Are we ready? So, I have 2 binomials. How do I multiply them? I have to
Foil.
foil, right? Carly said foil. We have to foil. We have 2 binomials. I must foil them. Foil. First, outer, inner, last. It's fine. First, outer, inner, last.
Oh, foil.
Yes, that is what Carly said. First one, 15 minus 5i, inner,
minus 6i
Outer.
last minus plus 2 squared 2i
2i squared. Hey, okay, it's good. So 2 things we have to do.
Yeah.
This middle, we have to combine like terms.
Negative
Negative 11i. Negative 11i. And 2 times I squared is the same thing as 2 times negative 1.
So then it's just
15 minus 2. 13 minus 11i. Whoa. Okay, so now it's a solid 14 minutes to work on your homework.
Wait, hold on.
Wow, 14 minutes, you could probably knock out half of it. Do you want me to pull up the book? Yeah, work on Alex or the book. I can pull up the page for you to start your homework.
I'm killing it.